Loeb predicted 60,000 kilometers. Hubble measured 60,000 kilometers. Exact match. When theoretical physics predicts reality to the kilometer across distances of hundreds of millions of miles, you're not looking at coincidence anymore. You're looking at validation of a model that explains something genuinely extraordinary about what Atlas is carrying through space. Loeb made a prediction based on pure physics and mathematics. He published a paper proposing that the teardrop-shaped anti-tail we've been seeing in Atlas images isn't gas or dust behaving strangely. It's a massive swarm of macroscopic non-volatile objects that separated from Atlas due to its measured non-gravitational acceleration away from the Sun. He worked through the orbital mechanics, the energy conservation equations, and the displacement calculations, and concluded that by November 30th, these objects should be positioned closer to the Sun than Atlas by approximately 60,000 kilometers. November 30th arrived. Hubble Space Telescope photographed Atlas from 286 million kilometers away. The anti-tail extension in the new image stretches exactly 60,000 kilometers toward the Sun, precisely matching what Loeb's theoretical model predicted. Here's what makes this confirmation so significant. Both pre-perihelion and post-perihelion Hubble images show the same anti-tail configuration. Back on July 21st, when Atlas was approaching the Sun, the teardrop pointed toward the solar disk. Now on November 30th, as Atlas moves away from the Sun after perihelion passage, the teardrop still points toward the Sun. The geometry remains stable across Atlas's entire journey through the inner solar system, maintaining consistent orientation and scale despite dramatic changes in solar heating and distance. Let me walk you through what this swarm theory actually proposes, because understanding the physics makes the confirmation even more remarkable. Atlas experiences non-gravitational acceleration, pushing it away from the Sun at about 0.002 times the Sun's gravitational force. That acceleration is tiny but measurable, and it means Atlas is being pushed outward slightly faster than objects that only respond to the Sun's gravity. Now imagine Atlas surrounded by a massive collection of objects that don't share this non-gravitational acceleration. Atlas gets pushed away from the Sun, these objects don't, so they fall slightly closer to the Sun relative to Atlas's position. Energy conservation and orbital mechanics dictate exactly where these objects must be positioned to maintain stable trajectories, and that displacement works out to about 60,000 kilometers at Atlas's current distance from the Sun. The swarm isn't small either. Loeb calculates approximately 1 trillion objects, each one macroscopic and solid, together carrying only a tiny fraction of Atlas's total mass, but presenting a combined surface area 100 times larger than Atlas itself. That massive surface area reflects 99% of the sunlight we see in the glow around Atlas, with only 1% coming from Atlas's nucleus. Remember, these objects don't sublimate like comet material. They're non-volatile, maintaining their integrity under solar heating, staying solid while normal cometary ice would be evaporating and dispersing into space. That's the critical detail that separates this from natural comet behavior. Natural debris around comets consists of ice particles and dust that sublimate constantly, changing composition and dispersing as solar radiation heats them. The particles lose mass, fragment, and eventually vanish. But Atlas's swarm maintains stable configuration with consistent geometry before and after perihelion. These objects aren't changing, they're not evaporating. They're holding formation across months of travel through varying solar distances and heating conditions. Loeb called it. He published the theoretical prediction with specific numbers derived from physics equations. Hubble tested it by photographing Atlas on the exact date when the displacement should be measurable. The observation matched the theory perfectly, confirming that we're looking at a swarm of non-evaporating objects maintaining stable positions relative to Atlas through orbital mechanics. Theoretical physics predicted reality to the kilometer across hundreds of millions of miles. That's extraordinary precision, and it validates the model that explains what we're actually observing. The swarm theory isn't speculation anymore. It's observational fact, confirmed by one of humanity's most capable space telescopes. If the swarm theory is confirmed through exact observational match with theoretical prediction, then these are objects that don't behave like natural debris. Natural comet material evaporates and disperses. These objects maintain integrity and formation. Natural fragments show variable composition as volatiles sublimate away. These objects show stable properties across changing conditions. Natural debris follows predictable patterns we've observed in thousands of comets. These objects follow physics that requires non-volatile composition and mechanical stability. Natural comet debris evaporates. These don't. That's not normal behavior for material traveling with an icy body through the inner solar system. That might be technology, or it might be rocky fragments processed by billions of years in interstellar space until all volatiles were stripped away. But either way, it's unprecedented in everything we've observed about comets. The swarm is confirmed through perfect agreement between prediction and measurement. Now the question becomes, what are these trillion non-evaporating objects that maintain stable formation around an interstellar visitor?